All right, good afternoon, everyone. Today, when you came in, I wanted you to go ahead and pull out your cover sheet that we were working on in last class and your spiral notebook if you have it. And I also want you to grab a ruler from the ruler drawer, as well as glue and scissors, because we're going to be basically setting up our interactive notebooks today. And I might not have enough glue for everybody, so go and you might have to share with your neighbor. Okay, so everybody go ahead and get that, and we'll go ahead and get started. All right, so if you don't have your spiral notebook with you today, please make sure that you bring it because um, we're going to be basically taking our notes and doing everything within it, okay? So on that first page, we're going to make a table of contents, and I want you to use the ruler to make nice, clean, straight lines, and I want you to divide your first page into sections, and I want you to label those sections. Section 1, I want you to label it the date. Section 2, the unit. Section 3, the topic. And then section 4 is going to be the page number, okay? So make sure instead of putting 1, 2, 3, 4, you actually put date, unit, topic, and page number, okay? And not only are you going to do that on the front, but you're also going to do the same thing on the back, okay? Because we need a table of contents as a reference. So then that way, as we're going through the year and you want to go back to studying, you're like, oh man, I don't remember what we did in domain and range. You'll have the table of contents right there. You'll have the page number, you have the unit, you'll be able to go back and reference it nice and easy. So if you need to, go ahead and pause this video and go ahead and make that happen. We're going to number our pages, but since not everybody has their spiral notebook today, we're going to do that on Monday because everyone should have theirs by Monday. So we're going to start. The red is what you should go ahead and put into your table of contents. You have the date, you have the unit number, you have the topic. The topic is the real number system, and then you also have the page, which is going to be page 1. So the very first page is going to be all this. And you're going to be taking notes by hand today. And so, make sure you write down whatever you feel is necessary. And, it's going to help you in your studying process later. Okay? So the real numbers system is basically real numbers that we use to describe quantities such as money and distance. Like if we're going to go buy something, it's $39.99, or if we're traveling to go see, our grandparents and they live, 300 miles away, we're using numbers here every day, and each of these numbers fall into one of these categories, okay? And so everyone's going to get this actual Venn diagram here. We're actually going to do something with this. So you're going to glue this Venn diagram right below where you're putting this top page of notes, okay? So you're going to glue that in. And basically we're going to talk about each one of these classifications for your real numbers, okay? Before we do that, I want to talk about the symbols, okay? Each of these symbols are the symbols that are associated with these different classifications. Of course, you have R for real numbers, okay? You have I for irrational. You have N for natural. Those are also known as your counting numbers. And you have W for whole. Now, with that being said, integers and rational, they don't actually, match up with like the first letter of what they represent. Real is R, and natural is N, irrational is I. But rational is the symbol Q, and integer is the symbol Z. And if you're wondering, do you have to write it the way that you see it here? No, you don't have to. Okay. I mean, for me, I'm going to kind of write it with like this double bolded outlined. I don't know what you call it, but I'm going to use that. I'm used to it. But you can just put a regular Z or a regular W, regular N. Just make sure it's capitalized, and I'll know which way you're actually you're actually classifying this. So what are these numbers? Well, natural numbers are your positive whole numbers, the ones that you count with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those. Those are your natural numbers. Your whole numbers are all of your natural numbers, including 0. So those would be 0, 1, 2, 3, 4, 5, and so on and so forth. Those are your whole numbers. Now, integers are your positive and negative whole numbers. So that's everything from like -3, -2, -1, 0, 1, 2, 3, 4, so on and so forth, in both directions, okay? So it's your positive and negative whole numbers. Rational numbers are numbers that can be written as the quotient of two integers. Now, quotient basically also means a fraction. So when you hear the word quotient, think fraction. I think that's where the Q comes from in the symbol, because quotient Q. But a quotient is a fraction, and rational numbers are basically numbers that can be written as a fraction. All right, so that's examples like 1/2, 2/3, -5/6. All of those are examples of rational numbers. But don't be fooled. Remember, whole numbers and natural numbers, they can be written, basically integers, they can be written as fractions as well. Because 7 can be written as 7/1. That's a fraction. Yes, it does simplify down to be just 7, but it can be written as a fraction. So don't be fooled by that. Also, rational numbers are like those decimals that repeat and never end, like 0.33 repeating. We all know that 0.33 repeating is 1/3. So even those non-terminating decimals, or those decimals that end like 0.25, even those can be written as fractions. Okay, so don't gotta be careful about those. Any number that cannot be written as a fraction is going to be an irrational number. Those are the ones where, like the decimals, they go on forever, but they don't repeat each other, and they can't be converted into a fraction. Those are your irrational numbers. But no matter what, whatever number we're dealing with, all of these are considered real numbers. They all go under the family of real numbers. And so when you look at this Venn diagram, if a number is a natural number, then that means that it's not only a natural number, but it's a whole number. It's also an integer. It's also a rational number, and it's also real. Okay, because if it falls right in here in this part of the Venn diagram, then it's all of these things as well, because it's on the inside of all of these things. If something is an integer, then it's not only an integer, but it's also a rational number, and it's also a real number. If something's irrational, then it's also a real number. Okay, so sometimes, excuse me, certain numbers can actually have more than one classification. And the thing is you want to list all the potential, all the different ways that you can describe this numbers. So what we're going to do now is we're going to have an activity. I have a list of numbers here that I want you to cut out, and I want you to glue them into your number set that describes them, okay? So you got different numbers like -5, 15.5, you got 3.14, so on and so forth. You have all these numbers, and I want you to cut them out, and I want you to glue them into this Venn diagram that we glued into our interactive notebook. And if you're kind of like, well, I don't know if I'm right or not, it's okay. I can come around and check if you want me to see if you got them in the right spot before you glue them down, okay? I want to take only 20 minutes to do this, and then we're going to keep going because we got more notes besides this. So go ahead and do this, and we'll come back together. Okay, so back in your table of contents, we have the same date, 8/19. We have Unit 1, and now we are going to be talking about setting interval notation, and we're going to do this on page 2. So completely new page, and it's going to be on page 2. Now, all the numbers that we've talked about and all these sets of real numbers can be described using set builder notation. And set builder notation uses properties of the numbers in the set to define the set. We usually use set and interval notation whenever we're talking about domain and range. And so we're gonna learn how to actually use it before we actually get to domain and range. So here's an example right here of what set notation looks like. Okay. It has a curly bracket, it has an X, it has a bar, it got some kind of like compound inequality going on, and then it has one of the symbols that we just dealt with, okay? But we don't read it as curly bracket X bar, so on and so forth. No, it actually has the set of words to describe all this, and it goes the set of X, the set of numbers X. So that's what that curly bracket and X first is, such that is that vertical bar. X has the given properties. Now, whatever is the compound inequality or the inequality that's listed right beside that vertical bar, that basically tells us, what we're dealing with. So we're not going to say X has the given properties. We're actually going to say, such that -3 is less than or equal to X, which is less than or equal to 16. And X is an element of the given set of numbers. So whatever numbers are defined within the set, we actually have to actually state what X is. What kind of numbers is X? And so in this case, X is an element of integers. So we can actually figure out, okay, well, what numbers could X be? Well, x could be the positive and negative numbers, or the positive and negative whole numbers that are in between -3 and 16 included. Okay, but this is how we say the set of x such that such that -3 is less than or equal to x, which is less than or equal to 16, and x is an element of integers. So we're going to take a look at these examples right here, and we're going to describe the set of numbers using set builder notation. So we have 8, 9, 10, 11, dot, dot, dot. Now that dot, dot, dot means that it's going to go on and on and on forever after that. So the way we're going to describe it is the set of x such that x is greater than 8, because we're talking about all the numbers that are greater than 8 but also include 8. Now, x is going to be an element of natural numbers, not integers, because 1, it's going to be all the numbers that are greater than 8. So that means that all of our negative numbers, and they're not even in the question. 0 is not in the question, okay? It's all the numbers that are bigger than 8, and if you notice, it goes 8, 9, 10, 11. It doesn't go 8, 8.5, 9, 9.5. So we're only talking about positive, the positive numbers that are bigger than 8. So that's why we use n for natural instead of any other number set. B are the ones that I love, because basically whenever they give you inequality, that inequality actually is the given property. That's the part that follows the vertical bar. So we write this as the set of x, so curly bracket x, the set of x values such that x is less than 7. And now x is going to be an element of all real numbers, because we're talking about all the numbers that are less than 7. All the numbers that are less than 7 are like 0, your negative numbers, like -1/2, so it's your rational numbers as well, but also the square root of 2. The square root of 2 is a decimal that goes on and on forever. It doesn't repeat, and it can be converted into a fraction. So all those numbers actually fall less than 7. So that's why we use R for all real numbers. Now C is a little bit different, okay? Because it's asking for your multiples of 3. Now your multiples of 3 are things like 3, 6, 9, 12, 15, 18, so on and so forth. And the way that we can actually get all those multiples of 3 is by taking 3 and multiplying it by a number. Now that number, like 3 times what gives you 3? 1. 3 times what gives you 6? 2. 3 times what gives you 9? That's right, 3. So 1, 2, 3, 4, 5, 6, so on and so forth, all of those are natural numbers. So the way we can describe this number set is by saying the set of x such that 3 times n. Now n is what we're actually going to describe here, because n is going to be the numbers that are actually going to get us our multiple of 3. That's what we need to describe here. So n is actually an element of all natural numbers, because when we multiply 3 by 1, 2, 3, 4, 5, 6, we're going to get all of our multiples of 3. Okay, now it's not going to be R, it's not going to be Z, because for one, multiples are only positive numbers. They're not your negative ones. So we don't even consider like -3 or -6 as a multiple of 3. It's only our positive ones. And then on top of that, zero is not a multiple of 3. So that's why it's not a W instead of an N. Okay. So we're going to look at these next 3 examples. If you notice, for D, it's going to be the set of x values such that x is greater than or equal to 1, and x is an element of all natural numbers, because 1, 2, 3, 4, they're listing, they're basically counting. For E, it's going to be the set of x values such that x is less than or equal to 3, and anything that's less than or equal to a particular number, or even just less than, is going to be the element of all real numbers. And the last one, the set of x values such that pi n. And n is going to be an element of all natural numbers, because your multiples, of course, are always your positive multiples. Now, if you look up here in this purple, up here in this top corner, I'm basically showing an example of what if you have multiple things that you need to represent in your set builder notation. So if I gave a number line where it was an open circle and everything less than -2, and then a closed circle at 3 and everything greater than 3, well, you literally are going to write out both of those inequalities and just separate them by a comma. So whenever you have multiple things that describe a set, you just basically put them all together, separate them by a comma, and then you describe what your variable is. So we have the set of x values such that x is less than -2 and x is greater than 3. And all the numbers that are described by being less than -2 or greater than or equal to 3 are all of your real numbers. So x is the element of all real numbers. Now, I know 0 is not included and 1's not included, but all the numbers that are less than -2 and all the numbers that are greater than or equal to 3 are real numbers. Now we're going to talk about interval notation. I know some of you guys are running out of room, so I want to go ahead and kind of make sure you have enough room to keep this all on page 2 because we're going to use page 3 for something different. All right. Interval notation is basically another way to represent a set of numbers. We use the square brackets to indicate that the endpoint is included, and then we use parentheses to indicate that the endpoint is not included. And sometimes when I like to do interval notation, I like to draw out a number line. It makes things a little bit easier to see because then if we can see it that way, then we kind of know exactly how to write our notation. So when it's -8 is less than x, which is less than or equal to 16, we know there's an open circle around -8, and a closed circle at 16 is everything that's in between them. So when we write out our interval notation, we'll have -8, comma 16. And because -8 is not included, we'll have a parenthesis. And because 16 is included, we'll have a bracket. For B, it's x is less than 11. So at 11, we'll have an open circle, and it's everything shaded to the left of 11. Now, because everything to the left of 11 includes 0, includes your negative numbers, it will go all the way down to negative infinity. So it'll be from negative infinity to 11, and because 11 is not included, it's going to be parenthesis, and negative infinity is not defined. There's no way we can actually have a number that represents negative infinity. It's always a parenthesis. So no matter what, around negative infinity or a positive infinity, it's always a parenthesis. Now C says x is less than 16 or x is greater than 5. So if we do a number line, I'm going to do it in different colors since they're overlapping each other. X is less than or equal to 16. So we have a closed circle at 16, and it's everything that's to the left of 16. Now x is greater than 5 would be an open circle at 5, and everything that's greater than 5, okay? Because it's an or statement and not an and statement like A is, it's going to be everything that falls in those intervals. And if you notice, it covers the entire number line. So it's not like we're going to have like two separate intervals here to describe the set. It literally is all real numbers, which go from negative infinity to positive infinity, and we put parentheses around both. Okay, so this one's kind of a tricky one. It wasn't meant to be that way, but I think when I was originally typing up, it ended up being a typo. But this was actually a good one because students tend to think, oh, well, because they're overlapping, it's just the part that's in between them. No, since it's an or statement, that means it's both of those together. However, if I did have x was greater than 16 or x is less than 5, then you actually would separate it. So you'll have negative infinity to 5, parentheses around both, and then the union 16 to infinity with a square bracket and parenthesis. So whenever you have multiple sets you have to describe, you always put a union when you're doing interval notation. So just to recap, when it's set notation, you're using your curly brackets. You're actually describing what x can actually be. Okay, and when you have multiple sets that you have to describe, you separate them with a comma. However, with interval notation, you're going to use square brackets and parentheses. And when you have multiple things that you have to describe, like in this last example that I do want you to add to your notes, you you separate them with a union, but you still write it together in one line. Okay, so go ahead. You guys are going to have homework for the weekend. If you have any questions, please make sure you come and see me during H2H on Monday. Well, actually, never mind. We have our department meeting on Monday. Just bring your questions to class, and I'll make sure I address them before you guys actually turn it in, okay? All right. Thanks for watching.